So in this section where we're learning about matrices, one of the most important and useful aspects of it is where we learn different ways to solve systems of equations. Now from Algebra 1, we learned that if we have a system of equations, one way we can solve it is by looking at the graph. So here, for example, I've graphed line 1. Line 1 is over here, this line, and then line 2 here, and I look at the intersection. So I get that the intersection is 1, 2. So that gives me the solution of that system. We've also got the substitution method. We've got the elimination method. But what we're learning from this chapter is that we can use matrices. In other words, we've got this inverse matrix method. And the inverse matrix method says that we can rewrite this this system in matrix form. So I've got 2, 5, 3, negative 2, and I've got xy here, and then 8, 1. And now we've written this system of equations in matrix form, and you can see that if I multiply out this left-hand side, I get exactly what it says up there. I get 2x plus 3y, and then it equals that 8 on the other side. 5x minus 2y equals 1. But what it's like is, it's like if this first matrix I'll call matrix A, the second matrix I'll do capital X, and then over here is the matrix B. So it's like I have AX equals B. And then we remember, okay, well, I can solve that because I'll just apply an A inverse to both sides. Like that. And then the A inverse times A is just the identity matrix. So really we have X equals A inverse B. Or in other words, XY, that's what big X is, equals A inverse B. So let's see how this looks. If I come over here to my little graphing program, or graphing app, if I do second matrix, and notice, let me see here, I put in this 2 by 2, I put in the coefficients, 2, 3, 5, negative 2. Okay, I've got that. Get out of that. Second matrix, I put in B. Whoops, let me do second matrix, edit B. I've got 8, 1. Now I'm just going to do A inverse B, and that's going to give me the solution. So dig this. Here I go. I go second matrix, A.
You can't handle this.
How to do this?
Here we go again. Hey, kidding me.
A inverse B. Okay, there it goes. And I hit enter, and look at that. I get 1, 2. See? So that's my solution. X equals 1, B equals 2. Now, we also have the Gaussian elimination. So we have the Gaussian method. And that's where we take the matrix, the 2, 3, and then we have 8, 1, like this. And then over here we have 5, negative 2, like this. And I put this matrix in, 2, 3, 8. So let's see what this is. Maybe I won't have an add pop up this time. Okay, so I do second matrix, and I want to edit, and I have this 2 by 3. There it is right there. 2, 3, 8, 5, negative 2, 1. Now I want to do this. I want to do second matrix, come over here to math, and I want to do RREF. Okay, so let me find, there it is, RREF. Second matrix C, there it is, and enter. And here's what I get. I get X equals 1, Y equals 2. See, I have 1X equals 1, 1Y equals 2. And you can just read that right off. Okay. So there's what we have. We have the RREF. So we do RREF. We have that. And we also have Cramer's rule. Okay? And Cramer's rule tells us this. We can say, I want x equals, okay, so if we're solving for x, here's what happens. In place of the x, we put whatever's on the other side. 8, 1, and then we have 3, negative 2 here. And on the bottom, I just put 8, well, not 8, sorry about that. I just put the coefficients, 2, 5, 3, negative 2. And I do the determinant of the top over the determinant of the bottom. Okay? So notice 2, 5, 3, negative 2, that's exactly this coefficient matrix up here. And then up top, since I'm solving for x, I replace the x's with what's on the other side. Now the y's, it's going to be a little bit different. So I've got 2, 5. The x's are where they're supposed to be. I mean, it's the x column. I leave that alone. But the y, since I'm solving for y, it's going to be 8 and 1. And then 2, 5, 3, negative 2. See? So notice this is going to be negative 16 minus 3 over negative 4 minus 15. See? Just doing the determinant. And this is going to be, let's see here, 16, 17, 18, 19, negative 19 over negative 19, which is 1, okay? X is equal to 1, which we knew that was the case. And then down here, let's see what y is. Well, it's 2 minus 40 over negative 19. And that is negative 38 over negative 19, which is 2. So there we have our solution, 1, 2. Now we can use these methods for a 3 by 3 as well, except now if we're talking about a 3 by 3 system, we don't have intersecting lines, but we have intersecting planes. And you can see here where I've used GeoGebra to find the point of intersection right here of these 3 planes. I've got this green one here. You can see I've got these 3 planes, and they intersect at 1, 2, 3. So we can solve these the same way. We can use the matrix method. So what we would have is we would have 3, 2, negative 4, 5, negative 3, 1, 7, 5, negative 2, times XYZ equals negative 5 to 11. And we can do A inverse B. Okay, so I think I have that one in here as well. So let's see here. So let me clear this out, go to matrix, and I think, let's see here, I think I have this. Yeah, 4, let's see here. Let me edit. I've got a 3 by 3.
I'm Hanks. I'm about to show you how to make a dragon. Sweet. No, too cute.
I wish I
Brave.
wouldn't get these ads. Okay, so 3, 2, negative 4, there it is. Now let me quit out of that and go into the other one. 3, 1. Okay, 3, 1 there. Negative 5 to 11. So remember, this was D and E. So I'm going to do D inverse E. And I get 1, 2, 3. You can see the solution there. Yeah, that's it. Now, we've also got this 3, 4. Okay, so there's 3, 4. Now, this is going to be the Gaussian elimination one. So notice if I quit out of that and do second matrix RREF. Okay, so I arrow up here, RREF. And I do second matrix. Let's see here, this one. I get x equals 1, y equals 2, and z equals 3. So we've got the RREF. Okay, so the RREF, so this is the inverse one. where we do A inverse B. We've got the RREF, and that's when we rewrite this as, 3, 5, 7, 2, negative 3, 5, negative 4, 1, negative 2, and then negative 5, 2, 11. And we do the RREF. Okay. Now we've also got Kramer's. That means that, okay, x is going to equal the top, is going to be the determinant. If I'm solving for x, I've got negative 5, 2, 11. This is going to be 2, negative 3, 5, negative 4, 1, negative 2. Okay. And down on the bottom, I've got just the coefficient. Yeah, like this. And we get we can use the calculator to calculate the determinant of the top over the determinant of the bottom. So that's x equals, now if we were solving for y, this 5, negative 2, 11 would be here. If we were solving for z, the 5, negative 2, 11 would be here. The bottom doesn't change. So we've got this. We've got the Gaussian method, we've got the inverse method, and we've got Kramer's rule. These are 3 new ways that we have to solve systems of equations.